Okay. Okay, you don't think have any of these been zooming today? Okay.
No, McKinley and Lloyd,
They left
checked out.
looking for stuff.
Oh, okay.
But, and then I don't think they can.
Okay. Well, I'm about to the point that I may just have to, and really, if you think about it, it might be easier to watch the videos sometimes rather than zoom in. So I'm kind of thinking, I don't know, that I may not Zoom with people. If I can get that to work with videos, I'm probably going to do it that way because it's just, when you add everything together, I think I can record Zooms, but I'm not sure if it'll load them into iMovie. I don't know. I'm just having trouble. This thing is just old and it doesn't hold many videos. It's just filling up the memory so fast. Okay, let me wrap my head around what I'm doing. Oh, why in the world is the answer book up here? I have no idea. I would have wondered where it was. Fifth block, second block, fourth block. You'd think I wouldn't have as many notebooks. It wouldn't be as crazy. Okay. It probably still should be up. So let me get my remote, and actually there's no really reason for me to have a remote over here because it doesn't work from my desk. I think it has to be at the front of the back of it, and it's not wanting to work very nice.
How long has it been since you changed the battery?
The battery.
In the remote?
Oh, good night. Well, they take them up during the summer and do stuff with them, so I don't know if they put new batteries in it or not.
So it's probably.
But you think from the side it should work?
If the battery is good enough, it should.
Yeah. It just makes me get up, which is okay. If I leave it up here, I do okay. Okay, where am I? We need in here. So, 86, 87. Oh, actually, that went through, that went 82, 80. That was right, wasn't it? Because it did 4 pages, so this should be 86, 87. I believe that's right. Y'all double check me. And this is factor with calculator or something like that. I do not consider it cheating if a teacher knows you have the program and they want to have you use it with just pink calculator or whatever. That's their choices. I know Ms. Newberry knows you have it. I know Coach Teichman knows you have it. So, you know, in college, they let you use a graphing calculator. Use whatever you got, whatever programs you have. That's why I archive them, because they're there. They're yours. You don't have to worry about losing them. Every once in a while, somebody's got an older calculator will come see me, like right when school starts, because they're fixing to go to college, and they're like, I need my formulas. So, 80, ooh, I skipped a page anyway, 82, 83. I think we're going to try to do a ACT page on Friday. I found one. It's not necessarily quadratics, but it's just a mixture of things that are pretty good since we haven't done many ACT things. Oh, that's not right. 82, 84, 86. And then today is the 3rd. And we said lesson 36. Factor with calculator. Okay, if I give you x squared minus 6x minus 7. Now, your calculator is going to solve that because that's what the quadratic formula does. It takes a quadratic equation and it solves it. But we don't want to solve it. We just want to factor it because sometimes we're factoring things. Sometimes we're looking for where the graph crosses the x-axis. If it's a y equals, if it's f of x equals. So factoring with the quadratic formula gives you a lot of, well, let me back up. The quadratic formula actually gives you several features. It gives you the answers to a quadratic equation. It gives you those zeros, the x-intercepts, or roots. I saw another place it's called. That's actually solutions. So it gives you the x-intercepts or the zeros of a graph. And this one's pretty easy. We'll factor it by hand. We probably have already done that at some point, but this is an easy one. X and X, and 7 and 1. That's my only choices. And -7 and +1 will give you 6. And I can't -6. I can't promise you that I wouldn't still factor easy ones like this by hand. But you're going to see some big ones here, especially on page 87, that are definitely going to be time consuming if you were trying to factor. So this would be a case where this is a nice feature. We'll have some crazier factors in when we do polynomials. Now see, yeah, I guess it's working. Okay, now take your quadratic formula, and I don't have my calculator up here, but I want you to type that in your calculator, and I want you to tell me what the solutions were. Now remember where those come from. I think I wrote that on a piece of paper earlier, and we'll talk about it, and it gives you -1 and +7. Is that correct?
Would we enter the parentheses? Is that what you're saying?
No. Quadratic formula, yeah, this won't, quadratic formula won't do that. Yeah, you're with me, you got it. Because here's what it's doing. It's solving this. It's taking x squared minus 6x minus 7 equals 0, and it's factoring it and whatever function that it's, whatever program's programmed into it. And if you remember, the zero product property says that one of these has to be 0. It said x minus 7 equals 0, add 7, you get this one, -6 plus 1 equals 0, x equals -1. And that's the work between there and there. Now my question is, if I know these, how can I get that? Do you see the relationship? It's pretty easy. It's x, and then opposite plus 1, and then opposite minus 7. So that's pretty easy. So do for me, even though it's a super easy one to factor, x squared minus 2x minus 3. Put it in your calculator. Tell me the solutions.
3 and -1.
3 and -1. Now let's get the factors from that. And this one would be x
-3.
minus 3, and this one would be,
X plus 1.
and the easiest way to check it is to FOIL or distribute. X squared, and then minus 3x and +1x is -2, and then there's your -3. Now, one thing you have to recognize is your calculator, and I'll show you what it's doing in just a second. We need to talk about GCFs, because I used to say this doesn't have a GCF, but it does. Everything has a GCF, and in this case, its GCF is an understood 1. Remember, 1s don't have to be put there, but you need to recognize that it's there. Because sometimes, and we're going to actually do some over on page 87, we're going to do some that have GCFs. Your calculator is quadratic formula. It is not a factoring program. I don't know that I've ever seen one, and if I did, I'm not sure I would necessarily like it. It's just all of that, the stuff, just the X's and things just don't set up necessarily like you want it to. Part of that is why they won't let you use certain calculators on the ACT, is they don't want one that will actually do the whole problem for you. And some of those more advanced ones do. Let's take one we did back in, I think we said it was on page 66, second block. It was 7m squared plus 41m plus 30. And we actually factored this one by hand. And I'm going to go back to 66 and get the factoring. But I want you to go put it in your program because we actually solved it. We did it all by hand. And I think we got 7m plus 6, and we got m plus 5. And so you probably got -6/7 and -5. Is that right? Okay. Now, I don't think you have any problem with issue with that one. But then you've got to recognize where this is, because again, you're using this to factor big problems. None of these are real painful on this page. Notice the opposite, which we've been saying, opposite. And so you've got -6. I just put the negative with the top, and there's your 6. And then notice your 7 is right here. Now, people consider these different, but let me actually show you that this one and these all tie to this one too. If you put a 1 under that, and we know anytime we want to make an integer a fraction, we put a 1 under it. Well, there's an understood 1 right there. See, this is 1x, this is 1x, and this one up here is 1x. And so if you picture it, all of them as fractions, you'll kind of see where the numbers are coming from. because the negative 5 is here and the understood 1 is there, and we just don't necessarily write it right there. But that'll help you recognize what your factors are going to be. It's nice. It's a nice feature. The GCF is 1. 7, 4, and 30 have no common factors. GCF is 1. So let's do number 1. We're going to do just like your classwork today. 2v squared plus 21v plus 27. And this one actually is not a hard one to factor by hand. The 27s, 1 are 27 and 3 are 9. So it really, and they're all positives. But again, that quick feature of the quadratic formula helps you. For time's sake, I'm going to say you got negative 3/2 and you got negative 9. Now let's stop right there and talk about that. If you don't get that, if you get decimals, then you've either gotten irrational or you got i's and you just don't realize there was an I out there. And you can look at the discriminant. And you've either copied the problem down wrong or you've typed it in wrong. So most likely, bottom line is, even if you copied it down wrong, you typed it in wrong. So make sure that you type it in correctly. You will get nice, rational answers. And then we call this factoring over the integers, because every number we see is an integer. 7 and 6, we don't put negative 6/7 up there. We don't put, well, here it's pretty easy on that one. But you only see integers, and that's what we call that factoring over the integers. Every number is not a square root and is not imaginary. Everything is nice or i's or imaginary, i's or irrational. So this one would give me, Miss Hallie, there you are. What's the factor to this one?
Positive 3. Or it'd be
Okay,
2v plus 3. Yeah.
V
Plus 3.
plus 3. And this one, go ahead and give me the second one.
V plus 9.
Okay? And you can always, and the full length's going to have a little bit to do with it in just a second. The 2v times the v is the 2v squared. I really don't have to worry about O and I, because if I check the L and the F, because 3 times 9 is 27. So, you've got it. That's it. GCF is 1. Let's do one more of these, and then we'll go to page 87. And even though we've got plenty of room, I'm going to do GCF on that page so that you see the difference. If you come to me and say, what did I do wrong? I can say, remember, on 87, we did the GCFs other than 1. So let's do 9n squared minus 18n minus 7. Now, by the way, these numbers underneath are not part of your answer. And I don't expect you to put it on your paper. That's your choice. This is just work, scratch work, to help us get these. Those were the solutions if it had been an equation. Now, when we get into the big polynomials like this, when we start graphing them, you actually you'll want to know what these numbers are, but you'll also want to know what the factors are. So, because those numbers are the intercepts of your graph. This is where that graph crosses the x-axis, if you make it a f of x equals. Okay, I think on this one, is it 7/3 and negative 1/3?
Yes, ma'am.
Okay. So, Sarah Margaret, what's my two factors going to be?
3 minus 7 and 3 plus 1.
Okay. We like it. It's nice. It's not something you want to depend on all the time. Like x squared minus 6x minus 7. I can factor that faster. But if it will help you, you can take advantage of it, and it will help. Let's go to page 87. And we're going to write up here at the top of the page, GCF, and I guess I should say GCF other than 1